Hello guys, welcome to my YouTube channel Antibiotic. So today we are going to learn about the antibiotics. The antibiotics are basically, you heard about that this is a kind of the drug which is given for the treatment of any kind of bacterial infection. It is found in it is available in the different forms, and also can be we can use when there is any kind of bacterial infection in our body, and doctors prescribe this as an antibiotic. Antibiotic means it is a kind of the substance or a drug which is used to treat bacterial infections or bacteria. It is used to kill bacteria mostly. That's why it is known as antibiotic. So today we will learn about the antibiotic and how it can be produced through a bio-based method through microbial fermentation. So there is a different type of antibiotics, and there are different categories of them, and some are chemically synthesized and some are microbiologically synthesized. Microbiological, like for example, penicillin is the best example of antibiotic which is commonly used for the treatment of infections, and it is the best discovery of antibiotic started for treatment of bacterial infection. And other antibiotics also there which are coming in the market for the treatment of different type of the bacterial infections. So let's start to learn basic things about the antibiotic first. Then we will learn about how to produce these kind of antibiotics in the lab at a scale of fermenter, and we will much more learn about the downstream processing and separations, purification, and then the actual active ingredients or ingredient form of the antibiotic. In this process we will use a bacteria killing antibiotic which is mostly tetracycline. It is a kind of the tetracycline antibiotic, and specially named as oxytetracycline, which is produced by a actinomycetes streptomyces ramosus, which is a kind of the microorganism that can produce antibiotic, and that antibiotic can be used to treat bacterial infections. So we will learn more about it. So here today we are going to talk about the antibiotics, which is a kind of the antibacterial agent. Antibiotics are basically a kind of the medicine which is used to kill bacteria or slow their growth. When antibiotics given, it will kill the bacteria when there is an infection by the bacteria. So there is a different type of antibiotics. One of them is known as oxytetracycline, which is dull yellow crystalline antibiotic powder, which is produced by Streptomyces ramosus and treat many kind of the bacterial infections. It has better absorption than tetracycline, also given to some patients which are sensitive to penicillin. So this is the kind of antibiotic which is basically having the mechanism of action role on the protein synthesis, to stop the protein synthesis. When oxytetracyclines act on the ribosome, it stops the synthesis of the protein which is required for the bacteria. The actual mechanism of action is it binds to the 30S ribosomal subunit and prevents the tRNA, amino acid tRNA binding A side, so that the proteins is not being produced. If we want to compare the tetracycline, oxytetracycline, the R group is the major one, which is in oxytetracycline it is OH and tetracycline it is only H. The oxytetracycline is much more effective. For the lab scale production of it, firstly we will start with the production at the fermenter level, then separation of the broth, and then precipitation by raising the pH of it, and after that getting out the dry powder of that antibiotic. So we will learn all these things in the lab scale production process. And the other method of solvent-based extraction process developed for the separation of the antibiotic purification of it. Firstly, we will separate the broth with a simple filtration, then increasing the pH, then by using some other different solvents, so separate the basic solution, and then re-extract with the dilute acid, and finally neutralize and making out the amorphous oxytetracycline as a product. Today we are going to produce the antibiotic oxytetracycline, which is kind of the antibiotic. We are going to start with firstly with the media preparation, the initiation of the starter culture, and then with the first inoculum we will go for the higher volume or the production of the antibiotics. And you know that the antibiotics produced mostly at the stationary phase, so we will incubate it for a long time. And the media is required is not just too much of that, but basically you require some amino acid and proteins in a rich amount, so that the antibiotic is produced in a very high amount. And mostly for that we can use the different protein sources and other things like corn step liquid or the malt extract and beef extract and other peptone like substrates. And some the carbohydrate substrate like the glucose or yeast extract and other things. So let's start with the preparation with the medium first. So guys, we have autoclaved our medium. Okay, now we are going to inoculate the culture. We are going to start the makeup of the starter culture. So you can see here, this is the microorganism we are going to use. This is the main starter culture we are going to use as a master stroke to make the pure starter culture and the initial inoculum. After that we will make it like this. In this we will inoculate and make a small inoculum. After that we will scale up to the larger volume and then produce in this fermentation medium for the production of the oxytetracycline. So let's start. So after 10 to 14 days of the incubation, when the stationary phase is there and the antibiotic is producing by this microorganism, we can see that too much of the growth, and this is the fermented production medium in which we have grown earlier from the starter culture and transferred that. Now it is ready for the purification of the antibiotic out of it. Okay, now we have just finished with the antibiotic production at last. Now we are going to do the antibiotic production in fermenter. We will prepare 1 liter of the medium, antibiotic production medium, and then transfer it into the fermenter, then autoclave it. After the autoclaving of the bioreactor, sterilization completion, we will inoculate the culture inside, previously grown culture inside this, and then do the antibiotic production inside the fermenter with the working volume 1 liter. Now we have prepared the medium, antibiotic production medium, and now we are going to pour it in the mixture. It is filled with liter working volume. Now we are going to autoclave this volume. So now we are ready with the fermenter, and we have just stored all the ports and all the lines, and we have just done with the port closing so that there should not be any kind of the opening. And now it is ready for autoclaving. Now we are going to autoclave it inside the autoclave. After that, we will just open all the ports and connect with this signal line, and then again we will start after adding the fermentation of this medium. Autoclaved the medium, and now we are opening it. You can see that the reactor is autoclaved now. Now we will remove it and then do the setup and do the inoculation. So after finishing the autoclave, now we are going to do the attachment of all the ports to the signal port, and then we will just open it and then prepare the reactor for the batch. Now we are going to do that part. When we lower down the temperature, the water level it should rise here in the outer jacket. Now you can see that the water level in the outer jacket is increasing here. You can see it is increasing. Because we already lower down the temperature so that the water is coming, filled water is coming inside and it is decreasing the temperature. And when it is filled over there, then we connect the outer line of it. So now the reactor is ready for the inoculation, and when the temperature reaches to the optimum temperature we have set it, and then we will do the inoculation inside this to the pipeline. We will connect and then do the inoculation inside. At the time of the sparging, you have to sparge the air when you are going to start it. You have to check that. You can see the air bubble inside. Okay, now it is ready for the inoculation and do the fermentation. The centrifugation, we will start it. Centrifugation. We are getting our culture pellet inside there. You can see we are using the centrifuge supernatant and use this pellet for the inoculation. Like this, we have done the separation of the liquid and use the pellet. Now we are finished with this preparation. Everything is set. Now the temperature and then the pH and all. Now after that we have prepared the inoculum. Now you can see this is the inoculum we have prepared after centrifugation and dissolving it in the normal saline. Now it is ready, and through the pump, by this pump it will go inside the bioreactor and it will be dropped down here. Okay, we will start the pump and set it as volume add. Now you can see here the inoculum is going up and it is coming through this pipeline. You can see here. Now you can see it is dropped down to the medium by this line. Batch is started, and we have just started the batch, and after the couple of days the stretching phase will come, and then the antibiotic production starts. And after the completion of the batch, we will do the separation of the cells, and then clarification of the growth, and then do the purification of the antibiotics by using some solvent based extraction method, and then purification of it, and then the drying powder. Maybe we are just developing that part, and then the analysis and other things. So now you can see that this antibiotic production is over in fermenter, and is showing the too much of the growth here. And the pH is also goes to down to 3 point something, so it is showing that the production is in the production phase. Now we are going to harvest the whole fermented broth, and then separate the cells, and then prepare the cell-free extract, and after that the cell-free purified broth liquid, we will do the purification of the antibiotic from it by using the solvent extraction based method. You can see we are harvesting the cells, whole fermented broth from this line from the fermenter. So now we have the fermented broth here, and then now we are going to centrifuge it, transfer it in the sterile with falcon tubes, and then we will transfer it into the whole bottle and prepare a fermented clear broth, cell-free extract of it, and after the preparation we will do the purification. So let's start the purification of this. The multiple centrifugation, the repeated centrifuge, we have clarified the broth, and now it is totally clear, you can see here, and we are going to use this cell-free extract for preparation for purification. We are taking 200 ml as a sample, transferring it in the right now. We know that it's in the acidic pH, and now we have to raise the pH up to 10, and when the pH is raised to 10, it shows the crystallization, and then the precipitation of the antibiotic come out automatically, And if you want to separate it more, so we can add some kind of the addition of the alcohol or other. But right now we are just going for the pH change, and then we will see that what will happen. Now we are going to see the pH first. So nearby 3.9. Now we have to raise it. Now you can see the pH is reached to now at 10. So this is the saturated alkaline condition where we have provided, and then you can see the growth is become too much of the turbid. It is showing some of the precipitations. Like this, it will show like this, the precipitated one on the bottom. And if we add the alcohol and other things, it will be shows much more clear, and it is totally precipitated out like this. Now you can see it is totally precipitated out, and it is now clearly seen here. So we will just store it at low temperature like 4 degree. When it becomes totally settled down, then we will just transfer and centrifuge it, and then dry it and make a powder of it. Purification of the antibiotic from the broth. Now you can see the bottom with this precipitated foam. And the clear transparent broth. We have just dried the sample. Now we are removing it. Now you can see this is the powder prepared with antibiotic. Now we are removing the powder. Firstly, we will crush it and make a powder of it. Now we are going to weigh it. So it is nearly 100 mg. So now you can see that we have made the antibiotic, that's powder form. You can see here. This is the powder we got from the fermented broth, and now we can see that around 200 ml of the broth we got this 100 mg of the antibiotic, and we can calculate like for the 1 liter it will come nearly by 500 mg, and if it is a purified, it is a crude, and to do the much of the purification like the active charcoal, the broth clear purification and all. So we can get the first like that. This is also the purified powder, this kind of the product out of the microbial fermentation, and up to 500 mg we are getting. It is a good amount that from the 1 liter of the broth, and you can see the price of the antibiotics are too high, and this is having the high value prices. So this is the whole, we can see the antibiotic production from the fermented broth, and how we have started with the initial culture, like the initial inoculum from the small volume to then the flask volume, then the 1 liter fermented volume, and after that the purification of it, and how easy the purification steps are there, and from the desiccation we are the final powder product of it. Thank you.